Yeah, the teacher is low. Like Megan and that's a great movie, actually.
It's terrible.
I didn't do that though. I like the iPad, not the cyborg.
Yeah,
that was something.
That code is terrible.
It's a work in progress, you jerks. Jesus.
Hey, I appreciate your artwork, my dude.
No, I don't like you.
Make a giraffe, man.
Mr. Sharp is a goat, not the giraffe. Know your terminology.
Alright. So, friends, listen up. Listen up. So, those 3 fancy cardstocks, I would recommend, and it's not required, but I would recommend, you notice it goes from 0 degrees all the way to 360 degrees. No, it's not by 1 degree increments, it's by the 30s, 60s, 90s, all the way through. I would recommend this. I'm sorry I'm talking. I apologize if you don't care about this unit. If you don't, go drop the class. Get to CP Algebra 2 right now, please. Okay? So, what I would strongly recommend, and would I do this if I was in high school? I probably wouldn't have. But I'm just trying to get in front of what I know might become an issue. So, on the backside of each of these, you're going to put the radian equivalent. I would then cut these out. Okay? Then you have flashcards. Do the 3 different colors mean anything? No. I just did the 3 different colors because it's like, hey, Mr. Sharp, I think I'm missing that one. What color? Okay, so I made it easier for me. So the colors of these have nothing to do with what quadrant they're in or anything like that. Okay? The colors are just 3 different colors that fit on cardstock. So what I would do is I'd cut each one out, and on the back side, I would, thank you very little. Who's it for? Not you. There you go. So, yeah.
Is that for our class?
I don't know. No, I don't give extra credit.
Dang. Can we get any extra credit for going to the conference?
No.
You did that for. Why do they all get that?
Yeah, and like 3 people show.
I show up every time.
Yeah.
Exactly. Okay, but my group, group wouldn't go.
Be a leader.
I can't. They're all juniors, and I am a sophomore. I didn't in your group.
So.
So. You get extra credit for like something.
Yeah, I'll take care of you.
Should we do the talent show because you're performing in it? Yeah.
Yeah.
I would do
How about if we start a mosh pit, we all get all extra credit?
Dude, I'm in.
Who are you?
Alright. So, notice, this is the first page of today's notes. So, with the 30 degree, on the backside of the 30 degree, I'd put pi over 6. Backside of the 45, put pi over 4. Backside of the 60, pi over 3. So get the radian equivalent amounts and put it on the back. I'm sorry, I wasn't fancy enough to get it on the back. I tried, and then I was going to do back-to-back, and it didn't go well. So I gave up. I'm sorry. I'm normally not a quitter. I usually try once and then quit. So the radian amounts I would put on the back. So 0 degrees is 0 radians, so we don't have it here. 360 and 2 pi, 0 degrees, 360, same place on the unit circle. So on the back side. Now, I will have more of these as we start getting into the right triangle trig. Okay? So all of these have, so this red one has a right triangle. It goes with it. This is a 30, 60, 90. This blue one is the 45, 45, 90. This is the 60, 30, 90, which is the same as 30, 60, 90. Okay? And so on and so forth. There's just things to recognize about it when you start going through and doing the problem. So let's go to last night's homework, if you don't mind. I'll give you those notes. They're coming. That whole thing that you just saw is coming. Not on me right now, no.
Okay.
Sorry.
I swear I'm going to make it go, because I don't want to.
It's getting there. I love it.
I don't want to interrupt the class.
Thanks, man. Love you, man.
I didn't do that.
All right. So, Trig C, what kind of questions did we come across on
44.
4-4? Number 4-4. 44 is 330 degrees. I don't even know what this one's asking for. So number 44, 330 degrees. Is that the right one, Sam?
Yeah.
Convert each degree measure into a radian in terms of pi. So if I'm going to turn it into a radian, I need to multiply by this.
Why?
It's always pi over 180. To go to a radian, to go to a degree, it's 180 over pi. It's reciprocal. So this is going to become 330 pi over 180. Then I can reduce that. Looks like 33. Then 3 goes into that. 3 goes into that. So 11 pi over 6.
I just didn't reduce.
Yeah, you got to reduce them. That's it. What else did you see on last night's letter C homework?
Go through a question from each section.
Okay. Hit me with a
Do 8.
number 8. Number 8, negative 1/3 pi. Is that the right one?
Mm-hmm.
Number 8. Okay, it says we want, using the inner circle as little as possible, to determine what quadrant or which xy axis. Okay, so negative 1/3 pi means it's going this way. Okay? So think of it this way. All the way, if I started here, 0 radians, this going this way would be negative pi. This is negative pi halves. Okay, and that's going clockwise. So negative 1/3 pi is 1/3 on this side or on this side. So this is quadrant 1, 2, 3, and 4. So negative pi thirds is like down here, so this is in quadrant 4. Because it's negative, it means it's going clockwise. It's just rotating around the inner circle. Yeah?
Can you do 21?
2-1. Negative 13 pi over 4. Is that what it is? Or is it just 13? 13 pi over 4? Okay, so right, let me ask you this. Do you think this has gone around the circle once?
Yes.
Yeah.
Do you think it's gone twice?
Yep.
No.
Yes, sir.
Maybe.
So
Nah.
2 pi is around it once. So let's do this. 4 goes into 13 3 times. What's left over?
3 and 1/4 pi.
Yeah, so it goes all the way around the circle 3 times, and then I'm left with pi fourths.
So it's
Okay?
So it's 1.
So where's pi fourths?
1.
It's in quadrant 1. So that just did this. Went 1, 2, 3 here.
So if you have like big numbers and stuff, you can always just like see how many times it goes in.
That's it. That's exactly it.
Nice.
All day long. What else? What else? What else?
You do like 34.
34. Convert the radians into degrees.
Wait, was that number 13?
13, yeah.
It says 11 pi over 4, which would be the fourth.
13.
That one was 21.
Oh, this was 21?
Yeah.
Sorry about that. I'm writing down the wrong problems. All right, and then which one? I'm sorry, someone just asked me for 34. Sorry. 34. 34. 7 pi over 6. So we want to convert that to a degree. So notice where pi is. It's on top, so I want to make sure I get rid of it.
180 over pi.
180 over pi. Pi's cancel. 6 goes into 180 30 times. 7 times 30 is 210. Done.
Done.
What else?
30.
30. Determine the reference angle for each. Okay.
Reference angle's just 30 fully or 60.
Yeah, so remember the reference angle on the last one. We're looking for basically what triangle it goes with. So it's either a 30 degree, a 45 degree, or a 60 degree angle if it's one of those. So think about it where negative pi over 6 is. That's down here. right? So that's this here, but what kind of angle is it?
Just 30.
It's a 30-degree angle. So the reference angle to this is a pi over 6 because that's the same as the 30-degree angle. Because pi over 6 is 30, right? Did I do that right?
Oh, so you can put it in.
Well, I'm just letting you see that where the degrees are. So I'm not taking a negative angle. I want to know this. So this is basically making this triangle here. So you have pi over 6, which is technically a 30-degree angle. It's just I'm using pi over 6. So then you know you got 1, 2, square root of 3 as far as the sides go. And this would be a negative, and this would be a positive. And that's always a positive for hypotenuse. So that's what we're aiming towards today. All right, names on those, pass them on up. Or if you're passing other things on forward, pass those on forward as well. So we're starting to get a little closer to people getting done with the quiz from a time ago. Well, we're still a little behind. You clear now? Yay. Good for you.
You are cleared?
Yeah.
Amen.
So I'm just going to drop a big old stack of paper on his desk. Here you go, pal. Do tomorrow.
There you go, man.
I'm gonna have to mark one down for big too.
All right, that's there and homework. That's one of them. That's it. Perfect. Thanks, man. I'll get that adjusted for you at around 5:45 tomorrow morning. Maybe 6 o'clock. Depending upon if the coffee doesn't get made right away.
That's alright. Never have inconvenience. Can you write get a glass instead of paper? On the board.
No, that's just nuance. All right, ready? So that cardstock that's with you, all of the answers that, the nice thing is all these answers are here for you. Honestly, my friends, if you learn quickly how to go between degrees and radians just as a go-to, and by flashcards, I have found that that's actually the best way to do it. I didn't discover flashcards until I was 37 years old and lived way too much of life. And I said, man, I could have made it through high school. I'm just kidding. But I knew flashcards were a good thing. Was I always the student that was using them? They seem like a good idea to me, but I'll do it next time. Okay? So I would honestly, on the backside of each of those angles, put the equivalent radian amount. That way when you're flipping through them, whatever order you want. Oh, okay. Whatever you want to do, I would just cut it out and have these flashcards. Sorry they're not on 3x5, but I made pretty colors for you. And again, the color of the card does not signify anything about that. It's like these don't relate to those colors up there. It's just I have 3 different pages. I wanted to make sure if you had all 3 colors, then you got all 3 pages. Make sense?
Yeah.
Cool.
When do people use the units that go in there?
Lot. It's a thought process. Honestly, Sam, everything about math is a thought process. The further you go in math, the higher level of thinking you can do. It's the only topic and subject out there that allow your brain to develop that cognitive skill. Okay? Guaranteed studies. If people take calculus, think through things a lot better than people who haven't. Okay? And it's the thought process, the developmental of your synaptic response in your brain that allows you to do it. We shouldn't call math the subjects. We should say this is thinking 1, thinking 2, thinking 3. That's what it should be called. That's all it is. Okay? And I can tell you that every person out there has a friend that hasn't done anything with education and now they're a millionaire. I know. We all have that friend. Okay? We all know that uncle, and hey, I heard that Bill Gates didn't. Well, you know what? You're talking about 1 in 6.5 billion people. So this is how we make you learn how to think. This is the exercise of the brain.
Cool.
That's all it is, buddy. So where are you going to use it? When you think through things later in life. Okay? All right. So this is where it's going to really start coming together. I know it is. Okay, do you agree that that would be a triangle that I just inscribed in our circle, in our unit circle? Okay, now remember that great circle, the unit circle always has a radius of 1. Okay, if you're using a triangle that doesn't have a radius of 1, or it doesn't have a hypotenuse of 1, all you have to do is divide everything by whatever that hypotenuse is, and you can make it equivalent to 1. And I'll talk a little bit more about that in a moment. So, ready, set. Okay, look at the blue triangle. Sine is opposite over hypotenuse, agreed?
X over 1.
So what is the opposite side in that triangle?
Oh, y.
Y. Over?
1.
Okay, now, I want you to see something real quick. Notice I have a point x comma y. Agree? If my hypotenuse is 1, this is always going to happen. My hypotenuse is 1, that's always going to happen. Where does this y also take place? Right there. So if you know what that point is, you know what that is every time. Cosine is adjacent over hypotenuse. So what's the adjacent?
Y.
X over 1, which is? And the tangent is opposite over adjacent.
Y over X.
Okay, now, this is one of the things, I didn't see this until I taught trig many years ago. Finally, it makes sense. If it can make sense in my mind, I promise it can make sense in your mind. Okay? Alphabetically, what comes first? Sine or cosine? Alphabetically, what comes first? Cosine. What comes first, x or y?
X, Y.
X, Y, Z.
Everyone okay with the alphabet? Does everyone agree that x comes before y? So, you told me cosine comes before sine. So C comes before S, yes? X comes before y. So cosine goes with x, sine goes with y. And tangent spells tix. I understand tix isn't spelled T-Y-X, but go with me. Got it?
Yep.
So sine comes later in the alphabet than cosine. Y comes later in the alphabet than x. So the later letters of sine and cosine. That's how I remembered it. It goes with this point. This point can wind up anywhere around here. If it winds up over here, you have a negative and a positive. Down here, you have a negative, negative. Over here, you have a positive and a negative. Okay? That is a huge thing to gain. So sine goes with y, cosine goes with x. Those are alphabetical, and tangent spells tix. Okay? Can I move on?
Yeah.
All right, now, all this is kind of a summation of what I said. Now take a look up there where it says cosine theta, comma, sine theta. How is cosine theta, comma, sine theta labeled up there? What does that look like when you just look at it in parentheses with a comma in between? Yeah, it is a point. So this is an x, y point. These refer to a point. So again, the cosine goes with x and the sine goes with y, as long as our hypotenuse is 1. Okay? So, I want to show you how we get our hypotenuse of 1. When you look up at these might not be working for you right away. Okay? Let me actually add. I'm going to go down here, insert a blank page. I'm just going to do this with this one first. Normally this was 1, 2, square root of 3. Do you agree? Right? Remember that?
Mm-hmm.
Which side's my hypotenuse right now?
2.
The 2. Everyone agree?
Yep.
If I want my hypotenuse to always be 1, if I divide everything by whatever my hypotenuse is, this becomes 1. This point right here in the x direction becomes root 3 over 2. This in the y direction becomes 1/2. So, I just said sine goes with what letter?
Y.
Sine goes with y. What is the sine of 30 degrees?
1.
Look at my point. 1/2. What is the cosine of 30 degrees? Root 3 over 2. Okay? Now, friends, let me ask you this. Can I draw my 30, 60, 90 here, 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 and here? So, if this is a 30-degree angle on each of these, that's our reference angle. Agreed? That doesn't mean from here to here is 30 degrees. That means that we're talking about this triangle. So this point right here is root 3 over 2, comma half. This point on the unit circle, because of our hypotenuse, we're making all these 1. Then I'm going to get negative root 3 over 2, comma 1/2. Down here, this point, they're both negative. Negative 1/2. And here. And it's, that one's a negative. Okay? Let's put it together real quick. Ready? Let me ask you this. So this is, what angle is this right here?
150.
150. So what is the sine of 150 degrees?
9.
What is the sine of 150 degrees? What's the sine, x or y?
Y.
1/2.
You're cheating.
No.
No way.
Okay? Let's do one more. Let's do one more right here. What is this angle right here? How many degrees?
30. 210.
Please look at the purple. 210. Is everyone with me on 210? What is the sine of 210 degrees? Negative 1/2. What is the cosine of 210 degrees? Negative. That's it.
Dang it.
Let's do one more. Purple. Let's do a different purple than that. Yellow. Yay. Can't really see it, Mr. Stirrup. Okay. How many degrees is all the way around to there? 330 degrees. Agreed? Because 360 is all the way around. My reference angle is 30 degrees and quadrant 4 is 330 degrees. What is the sine of 330 degrees?
Negative 1/2.
Negative 1/2. What is the cosine of negative or 330? That's it.
Oh,
You're telling me the point. You're telling me the point as long as you have the hypotenuse being 1. Okay? It works the same with the 60-degree angle. Okay? And that's all we're doing on the previous slide. Now, I added this slide as an addendum, but we're looking at those points on the unit circle, and they're like this. Let me add one more. Insert blank page. Okay. So tell me, let's use a better color than that so you can see it. We had negative root 3 over 2, comma 1/2. That went along in what quadrant? What quadrant am I in? 2?
2.
Right? It's over here. Agree? Okay. Tangent spells what? Ticks. Okay, so if that was over there, that was 150 degree. Tangent spells ticks. So that's y over x. What's my y value there? What's my x value? Careful. Negative root 3 over 2. Agree? A positive fraction over a negative fraction will result in what sign and fraction? Negative. Everyone go okay with negative? What do I do with 1/2 and I divide this? What happens? 1 over root 3, so negative 1 over root 3. Guys and girls, when we are in trigonometry, we're not going to worry too much about rationalizing these. Sometimes we might, but sometimes we might not. You want to know why we don't rationalize that? What's the cotangent of 150 degrees? Cotangent is the reciprocal of tangent, right?
Negative root 3 over 1.
Negative root 3 over 1. You nailed it. So if you don't rationalize them, you can get to the reciprocals quickly. Okay? This stuff's awesome. I love this stuff. Okay? So let me go back to that one slide. There was a whole bunch of information on it. Okay? Now, what are they doing with this? Well, this is basically just quadrant 1. We took 1/4 of the circle, focused on quadrant 1. We embedded our 30, our 45, and our 60 degree as our reference angle. And what they did is they made each of the hypotenuses 1. How do you make the hypotenuse 1? You divide by whatever the hypotenuse is. A hypotenuse is always positive no matter what. Okay? These points exist all the way around. So the sine of 60 degrees is root 3 over 2. The cosine is 1/2 of 60 degrees. Okay? So as long as you have embedded inside your unit circle this triangle, it's a right triangle, it's either the 30, 60, 90 or the 45, 45, 90. As long as we made the hypotenuse 1, we can always figure out the point that's on the circle. Okay?
Wait, so it's a hypotenuse? Like, how do you know which one is the hypotenuse?
I'll let you figure that out. It's always opposite the 90. It's always the longest side of a right triangle. Not just today or yesterday, all the time.
So this is only for right triangles?
Only right triangles. We're not worried about law sines or law cosines. That's a whole different issue we'll cover later.
How do you do the ones that are like not
Is this related to what's up there?
bow tie? It's like,
They're not what?
you know how you like a bow tie shape, but how do you do the ones that are like,
I'm only worried about the 30, 60, 90 and the 45, 45, 90. That's it.
okay.
And where it happens in quadrant 1, 2, 3, and 4. All right. So this is the 45, 45, 90. You with me? Let me draw the 45, 45, 90 like this. That's 45. That's also 45. So I get 1, 1, root 2. 1, 1, root 2. My hypotenuse is root 2. Mr. Stewart, my hypotenuse isn't 1. What do I divide everything by?
Root 2.
So divide everything by root 2 over root 2 over root 2. Is that okay?
Yep.
So what does this point right here have to be if this is a 45 degree angle? 1 over root 2. 1 over root 2. This point here, we have negative 1 over root 2. 1 over root 2. This point down here, negative 1 over root 2, comma, negative 1 over root 2. This point here, 1 over root 2, negative 1 over root 2. Okay? Let me ask you this, friends. Is it possible that we get negative values when we find the sine, cosine, and tangent of things on the unit circle? Do we have any negative values up there? Yeah. So, all sine, cosine, and tangent are positive, and their reciprocals are positive in quadrant 1. In quadrant 2, sine is the only positive one. In quadrant 3, tangent's the only positive one. Why is tangent positive when they're both negative? Well, tangent's y over x, so negative over negative is
Positive.
so tangent's there. And then quadrant 4, cosine. Okay? So a lot of times we learn this way. All students take calculus. Okay? All of them are positive. Sine and its reciprocal positive. Tangent and its reciprocal are positive. Cosine and its reciprocal are positive. Now I have to thank Hunter Martin. I know y'all don't know him. He's a gunnery sergeant in the United States Marine Corps now.
Oh, I know.
He's a former student of mine. And he's like, Mr. Stirrup, I don't see this all students take calculus. I said, all right, Hunter. And this is one of those where, Stirrup moments that I probably shouldn't have said, gee, Hunter, how do you see it? Because he told me. And you don't want to know how he saw it?
Yeah.
All strippers take cash.
Nice.
Huh.
It's different.
Some old hippie comment. The Marine would know that.
Never learn about strippers and hippies in stirrups class. I tell you, we're out of control. Okay? Hunter Martin, love that kid. All right. So they're talking about compare all of the 30, degree, which is the pi over 6 reference angle given the coordinates. Okay? We just did this one, didn't we not?
Yeah.
So the 30, 60, 90 is like this, where I got 1, 2, root 3, so I divide everything by 2. So this becomes root 3 over 2 and 1 over 2. And this is the negative root 3 over 2, comma 1/2. 3. And this is both negative. And this is the x component's negative. And again, these are just points, friends. There's nothing more to this. Okay? So, we can find the sine, we can find the cosine, we can find the tangent, and we can find the tangent because this tangent is the sine over the cosine. The sine is the y over the x, right? And then take care of it. All right? 60. Let's figure out this. We good there? So divide each of these by 2. Ladies and gentlemen, do you see anything different? This is I'm using the 60-degree angle versus the 30. I flip-flop the x and the y value, right? And then here's where I would have my negative 1/2 and my root 3 over 2. Down here I have my both negative and that is 1/2 comma negative root 3 over 2. Okay, so the sine of 30 is the cosine of 60. Okay? So we flip-flop the values. And then I think the last one is our 45. Lastly, the quadrantal angles. Okay? Did I skip one? Did I do one?
I don't know. It's on their slide.
Oh, is it? Where's it at?
It's not there. Don't worry about it.
Is it the 45?
Maybe.
Okay. 45, you just have 1 over root 2, 1 over root 2. Blessing you.
Wait for so
Bless you.
30. That's cool. For 30, it's for the first quadrant it'd be root 3 over 2.
For the 30?
Yeah. And you flip them to 60.
Yeah. So where's the 30? Where did 30 go? That's it. There's my 30. So that's 45.
Oh, no. Oh, God. No,
So-
Wrong way.
Four
It was right after
1,
45.
2, 3, 4, 30. So 30, I had root 3 over 2, comma 1/2.
Yeah.
For the 60, it's 1/2, comma root 3 over 2. So they honestly just flip-flop. Last one, I think, or close to it. 2 more. Okay. What happens when we land here, or here, or here, or here? So that's the point 1, comma 0. Agree?
Yep.
So this is 0 degrees or 360 degrees. Agreed?
Yeah.
Or 0 and 2 pi, as far as the radians go. So, hey, what's the sine of 0? What's the y component?
0.
0. What's the cosine of 0?
1.
1. This is our 90 degree. This is 0, comma 1. What is the sine of 90? What is the sine of 90? What is the sine of 90?
0.
It's the y value. Sine goes with y.
1.
What's the sine value? What's that y value up there?
1.
What's the sine of 90?
1.
Good. What's the cosine of 90?
0.
0. This one we have negative 1, comma 0. What is the sine of 180 degrees?
0.
0. What is the cosine of 180?
-1.
Negative 1. And then this one down here is 0, comma negative 1. This is 270 degrees. Agreed?
Yep.
What is the sine of 270 degrees?
Negative 1.
Negative 1. Cosine of 270?
0.
All right, here comes a curveball. What is the tangent of 0 degrees? 0 tangent is what over what? X. Y over x. So 0 divided by 1 is? 0. What is the tangent of 90?
0.
Y over X. Y over X. 1 over, which is? 1 over 0 is?
No solution.
No solution, it's undefined.
Oh, yeah.
Okay, so this is 1 divided by 0, that's an undefined term. Okay, and then this one would also be undefined because this would be negative 1 over 0, it's also undefined at 270. Okay? All right, let's see what we do. You guys have those notes. Let's walk through them. Cosine of pi over 2. Pi over 2 is 90 degrees. What's the cosine at 90 degrees? Huh?
0.
Undefined.
Cosine and sine aren't undefined. Pi over 2 is 90 degrees, right? So it's up here. This is the point. 0, 1. We're looking for the cosine. 0. Good.
0.
Okay. Pi over 6. That's a 30-degree angle. Happens in quadrant 1. 30-degree angle in quadrant 1. It's 1/2, isn't it?
1/2 over.
It's 1/2.
Just 1/2. So pi over 6 is a 30-degree angle. So I went back and I thought the 30, 60, 90. Okay? And then I realized 30, 60, 90, the corner of it, when the hypotenuse is 1, is root 3 over 2, 1/2. And the sine is the y value. Okay? Guess what next set of flashcards looks like? You like purple? Next set will be literally going through these. Sine, cosine, tangent of all of those angles. And nailing them like this. Okay? 2 pi over 3. 2 pi over 3 is a 30-degree angle, I believe,
60.
in quadrant 2.
I think it's 60.
It's a 60?
Yeah.
Thirds? 2/3?
No.
2/3 of pi. What's 2/3 of pi? 2/3 of 180? 120. So it's a 60. 60-degree angle. It's a 60-degree angle. Sine.
Over 3 over 2.
Is it positive or negative?
Positive.
Negative.
It's positive. Definitely positive.
How wrong is negative?
Yes. Quadrant 2.
Root of 3 over 2.
Root 3 over 2. It happens in quadrant 2. What also happens in quadrant 2? Sine is positive. Okay? Cosine, 7 pi over 4. So it's happening in quadrant 4. What do you know about cosine in quadrant 4? All students take calculus. What happens in quadrant 4? Cosine's positive, so it's definitely positive. 7 pi over 4 is what angle?
45.
I'd say, let's see, it's got to be,
315.
how much?
315.
315?
Yes.
We're right? Is it 315?
I don't know. I'm looking at a cheat sheet.
Cool, that works. Let's go to the first page of the notes, right?
Yeah.
First page, 315, 7 pi. Thank you. So that's a 45-degree angle. 45-degree angle, it's positive, is 1 over root 2. Done? Nice. Okay. Is there anything more on this? Oh, sweet. Okay, so, my friends, this starts getting goofy if you don't start getting the angles and the radians down. Okay? So that's why you have that first set of flashcards. How do you do flashcards? Well, you've seen kids walk around campus doing this. And they're not checking their Instagram and their Insta-tweet Facebook page, right? They're going through it. Okay? They're going through them. They're getting them down. They're getting it into rote memory. So I would say we have worksheet trig. What? D? Yay! Get out of here, guys, girls. Take care of one another. Have a great day.